Hey everybody, welcome back today to another episode of Retro Tech. I've got one of the most popular, according to eBay sales, monitors today that I'm going to be covering, and it's just a little monitor. It's the 8041Q PVM by Sony. And first, I'd just like to take a brief second to show you a little bit of the statistics on this particular monitor. We'll look through some of the Sony's direct marketing materials here real quickly, and then we'll get into our repair video. So first off, again, we are looking at the 8041Q, which it was originally designed as a field monitor, so it was used for video production when you were out somewhere and needed to shoot and needed a live feed monitor to see what your picture was like at the scene. Now this one does have 250 TV lines of resolution. These monitors, different models, will go up to 450 lines. They do offer support for nearly every kind of analog video input, and you just need to check the exact model, but this one supports things like BNC, audio video, and then it also through composite, and then you've got S-video, RGB, and component, and then you can loop through on some of those, and it also has some external sync input control, and it will switch between 4x3, 16x9. You can actually use a DC power supply with this one if you have the correct power supply, or you can use even battery packs if you happen to have those. Lots of screen controls, and these were also used in studios for extra monitors too. A lot of accessories. There is some good information here. I will link to this particular little service or detailed manual. It also goes into some of the features of the different brands. So just in case you want to look at a little bit more, this will be in the description of this video. But now let's go ahead and jump into our repair today, and we can go ahead and see what's wrong with our particular unit, because I was able to get it fixed up. But just to begin with, this is the 8041Q that I had been working on this week. It again, right here on the screen, I'm running it through RGB to begin with, but again, it does work for component and composite and S-video. So it's a great little handy monitor, especially if you want to have something on like a workbench. But the problem with these is sometimes you'll be using them for a while, and all of a sudden, without even like really any kind of warning, sometimes color will just go out. I've got other ones that where the power will just go off, or all of a sudden the screen will start acting crazy, and it's all mostly related to the same single issue with these. This particular one, though, as you see on the screen behind me, after a while the color would just cut out. So that's no good. Sometimes you could bang it on the side and it would come back on, or you could turn it off and turn it back on and the color would come back on. So that kind of is a hint that there's probably a loose joint or solder point inside the PVM that we need to address. So to do that, we're obviously going to have to get inside this PVM, and that's pretty easy. There's only 4 chrome screws on each side, and then once we remove the shell, we'll be able to access our boards in here. Now, this is the board we're going to be working with today. This one controls all the color and other processes that are done on this monitor. It's not the geometry board. This is the opposite from the geometry board. So the first thing I'm going to do is I'm just going to get the board out, and then we can talk a little bit more about what the problems are. But primarily the problem is the solder on this board, or the solder mask or something, because over time, due to the fact that this monitor is so compact and heat can build up, the solder joints again develop cracks in them and points where they're basically cold solder joints that you can no longer, current will be interrupted very easily through it. So the number one thing after inspecting this monitor is to go through and resolder this entire board. And we're going to try to reflow solder on all the through-hole capacitors, resistors, and any other kind of diodes or anything, but I will not be specifically going through and resoldering any kind of surface mount components. But what I am doing is I'm using some flux, and then I'll go through and just simply heat up my iron tip and use a chisel tip and get in there and reflow that solder on just about every point on this board. And when we get a close-up, you'll be able to see how much better it'll look afterwards. But the main thing is that over time, the heat inside of this monitor, and then also the fact that it's so compacted as compared to like some of the other larger monitors. That's the reason we're going to have a lot of troubles where we'll have interrupted signals, whether it's being from power or from even just colors and things. This board, it not only controls a lot of your colors that you can adjust if you need to make a color adjustment, but this board actually has a lot of the components that would normally be on the neck board of a larger 14-inch or 20-inch CRT that Sony made. A lot of those components had to be moved over to this board simply due to the space limitations on the actual size of the CRT for the 8-inch model. So again, I'm just showing you some basic techniques here on how to reflow solder. The important thing is to not make sure that you're introducing too much heat to the board. You don't want to damage any other components or damage a trace or a pad or anything. So the most important thing is just to go gradually and methodically and take your time. And then you can clean it off with rubbing alcohol. I went and took the board outside so we could get a better look at how it looks afterwards. I'll show you some of the things close up here that I did reflow the solder on. I maybe even pause some of these points, but I can give you some good examples here. So you can see how this looks like a freshly brand new soldered board if you look real closely to a lot of these components. And these were the ones that I did resolder or reflow the solder on. Every point on here that would have been through hole, as far as like here's some of these through hole electrolytic capacitors. Here's an inductor, and then there are other things like resistors, but we'll just look through here. There were some other things I did have to reflow solder on, but you can tell there's a lot of things compacted. Also the potentiometers, reflowed solder on all those points, and not so much though these little surface mount resistors or anything like that. I was not trying to reflow the solder on that because I didn't want to damage anything. I also did all the connection points where the wires were connected to on the other side. Also the chips, any of those. And also a lot of the little transistors or ICs, they all had to get reflowed. But as you can tell, there's a lot of components on this. And that's the problem with them. Again, it's just that there's so many components that the solder mask is just, it's really old at this point. These are from the early to mid 90s, and that's the biggest problem. Not even the capacitors. The capacitors on this one were in really tip-top shape still, and none of them failed. I tested a couple of them. They were in great shape, so that's the problem with it. It's sometimes it can be capacitors because if it's got a lot of use on it, but it's worth going in there and checking because most likely it is this solder that's just kind of wrecked or gotten old or, had some cracks develop on it. And just wanted to show you on the front of that board briefly how just there's tons of components on this board. That's why you have to be very slow and take your time because it can't, you don't want to damage that board and have to replace it. Those components on there are so small and compacted on top of each other, it'd be difficult to replace something, one of those surface mount, even chips, or if you damaged anything on there, you're looking at as a difficult repair at that point. So again, the B board, you can see right there is the specific board. The rest of this time after we've gone and put it back in the brackets, we're going to reconnect all these cables and then run some tests on the monitor, and hopefully we'll have color and we won't run into any more troubles with any other processes this board does as far as comb filters and things like that. That's what's controlled on this board as well. And once I get all that put back together, the ground connection on the circuit board does go on the top part of the frame you just saw there, and then it's just the two screws on the side. And we'll be ready to start running some tests on here. I have done some videos about this style monitor before, so if you want to check out those videos in the past, you can on the 8-inch and how to calibrate them specifically. Today we're just looking at this color repair, and it works perfectly now. So what I did was I just turned it back on and let it run for a while, and then I came back and power cycled it again and then let it run for a little while longer. And ever since I did that solder reflow, I was not able to get the black and white glitch to show back up. So I'm assuming that it was 100% that solder problem, because again, I could not get the monitor to go out of color unless I specifically selected black and white. So that's something to check out if you have bought one of these 8-inch monitors, or if you even consider looking at one on eBay and it's listed with a color problem or any problems at all. This should be the first part you start with, is just getting inside and doing a visual inspection. And you may need just to go through and reflow solder on all the boards, and that'll save you a lot of trouble with trying to troubleshoot, trying to say that a specific component's gone out to cause the black and white issue. That's kind of like, thinking you're almost thinking like the wrong way around the problem. You got to try to think of what's causing the problem, and it could just be, again, cracked solder joint, and nothing to do with a component failing. So that's where CRT repair may be different from troubleshooting some other things, where you could specifically go in and look at a certain component and think that's what's causing the problems, when in the end it was just a solder mask problem. I did clean this monitor up. It actually got sold to a Patreon member named AJ, and it's on the way to you right now, AJ. I hope you enjoy it once you get it. I do again think this is a great monitor for anybody looking for something that's like on your test for a bench, or like your working environment. If you have just a small place to put a CRT and you need to test different video signals that are analog, really nothing works better than this. You can't really find a great, I don't think, flat screen to do the same things that you could with this. Even though this is long and a little bit bulky, it's going to save some space and get you a good test monitor if you're doing things like modding consoles or repairing things or doing anything with analog video. I'd highly recommend this monitor, and it still is reasonably priced at generally under $200. You can pick up a good working condition one. Now, that's it for today's video, guys. I thank you for joining me, and please, if you have any questions about this repair, please, again, leave a comment below. And if you would like to go back and again check out any of the other calibration or service videos for the 8-inch models, I will link that in the video as well as in the description. And just look for another video next week, and have a wonderful week yourself. I'll see you guys next time with some more retro content.